Hello guys, we are chemistry students at the 10 November Institute of Technology. We will learn about ammonia to fulfill the assessment requirement for the course on the element inorganic compounds. So introduce our best team. There are Nurma Sulistiawati, Nur Farida, Hafiza Salsabila, and Novi Saulina. Let's be watch.
Ammonia profile. Ammonia is naturally present all around us and can be used as a building block in anything from ammonium nitrate fertilizer to household cleaner. Ammonia occurs naturally throughout the environment in the air, soil, and water, and also in plants and animals. The definition of ammonia. Ammonia is one of the most commonly produced industrial chemicals in the United States. It is used in industry and commerce and also exists naturally in humans and in the environment. Ammonia is essential for many biological processes and serves as a precursor for amino acid and nucleotide synthesis. In the environment, ammonia is part of the nitrogen cycle and is produced in soil from bacterial process. Ammonia is also produced naturally from the composition of organic matter, including plants, animals, and animal waste. The purpose of this video is to get to know about the origin of ammonia, the application in various fields, and its economic value. Here's the table of contents. First, we will learn about the application of ammonia or what ammonia is used for, especially in daily life. Second one, we will get to know about the history, the origin and manufacture of ammonia used in everyday life, and then we will get to know about the economic value, analyzing the economic value of ammonia. Application of ammonia. For industrial uses, ammonia provides a route to a wide range of nitrogen compounds, which includes fertilizers, plastics, and explosives. For household uses, ammonium hydroxide is an ingredient in many household cleaning products used to clean variety surfaces, including tubs, sinks, toilets, countertops, and tiles. So what cleaning products contain ammonia? Some of these products are ammonia cleaning solution, like window cleaners, floor polishing waxes, furniture polish, drain cleaners, toilet cleaners, bathroom cleaners, multi-surface cleaners, glass and mirror cleaners. Use of these products at home may lead to exposure to ammonia.
Work for ammonia. About 90% of ammonia produced is used in fertilizer to help sustain food production for billions of people around the world. Ammonia has other important uses, including its use in household cleaning products and in manufacturing other products. Ammonia uses for. It is found in many household and industrial drain cleaning solutions. Household ammonia cleaning solutions are manufactured by adding ammonia gas to water and can be between 5 and 10% ammonia. Ammonia solution for industrial use may be concentration of 25% or higher and are corrosive.
Part 2. History. The origin of ammonia. Ammonia takes its name from the worshippers of the Egyptian god Amun, the Ammonians, because they used ammonium chloride in their rites. Ammonium chloride, also known as sal volatile, occurs naturally in cracks near volcanoes, and when it's warm, it decomposes into the pungent ammonia. The occurrence of ammonia. Ammonia occurs in nature, primarily produced by anaerobic decay of plant and animal matter, and it also has been detected in outer space. Some plants, mainly legumes, in combination with rhizobia bacteria, fix atmospheric nitrogen to produce ammonia. Nowadays, in 2020, the worldwide ammonia production capacity was 224 million tons. Actual production was 187 million tons. It ranks 9th among chemicals produced globally. Ammonia is a colorless pungent gas that is familiar to us as the smell of urine. In fact, probably no other compound can be identified by its smell and correctly named by as many people as ammonia. It can be detected in the air at a level of only about 50 to 60 parts per million, and at levels of 100 to 200 parts per million, it sharply irritates the eyes and lungs. At even higher concentrations, it makes the lungs fill with fluid and can quickly cause death. Biologically, ammonia is a toxic waste product of the breakdown of some amino acids, which is why it is converted to urea in the liver and then excreted in urine. Once outside of body, microbial action decomposes the urea back to ammonia. Ammonia is also a useful fertilizer since ammonia consists of nitrogen and hydrogen has been known by its odor since ancient times. It was isolated in the 18th century by notable chemist Joseph Black from Scotland, Peter Wolf from Ireland, Carl Wilhelm Scheele from Sweden, German, and Joseph Priestley from England. In 1785, French chemist Claude Louis Berthollet determined its elemental composition. The Haber-Bosch process. Industrial ammonia is made by the Haber-Bosch process, which converts nitrogen gas in the air into ammonia. This process was discovered by the German chemists Fritz Haber and Carl Bosch in 1909, just in time for the beginning of World War I. The Haber-Bosch process, which takes place at 400 to 500 degrees Celsius and about 200 atmosphere pressure in the presence of an iron catalyst. Hydrogen is obtained from the reaction of methane and steam, producing carbon monoxide as a byproduct. Hydrogen produced from this reaction also reacts with oxygen from air, producing water and leaving nitrogen behind. The air contains 77% of nitrogen. These gases are then compressed and delivered to the reactor where ammonia is produced. And then these gases are cooled down and ammonia is liquefied, ready to be topped off. Unused hydrogen and nitrogen are recycled back to the reactor. The Haber-Bosch process used Le Chatelier's principle to maximize ammonia production. Le Chatelier principle tells us that increasing pressure will favor the site with fewer moles, for our case, the production of ammonia. It would make sense to conduct the reaction at a very high pressure, but we must also remember that it is expensive to build and operate a plant that can withstand such a high pressures. Therefore, a compromise pressure of 200 atmosphere is used. Since the forward reaction is exothermic, it would make sense to conduct this reaction at a low temperature. The compromise temperature is 400 to 450 degrees Celsius, which is not exactly low but not too high. If a low temperature were used, the rate of reaction would be very slow. Though the exothermic reaction would be favored, it will also actually take a long time for equilibrium point to be reached. So, a compromise temperature of 400 to 450 degrees Celsius ensures that the reaction proceeds with sufficient yield. The yield of this process is 10 to 20%.
Economic value of ammonia. First, in world industry. In 2020, ammonia were the world's 413 most traded product, with a total trade of $6.46 billion. Between 2019 and 2020, the exports of ammonia decreased by 10.6% from $7.22 billion to $6.46 billion. Trade in ammonia represents of 0.039% of total world trade. Export and import. In 2020, the top exporters of ammonia were Saudi Arabia, up to $2 billion, Russia $1 billion, Trinidad and Tobago $824 million, Indonesia $430 million, and Canada $397 million. For import in 2020, the top importers of ammonia were India up to 1 billion US dollar, United States up to 781 million US dollar, South Korea 412 million US dollar, Morocco 328 million US dollar, and Brazil 322 million US dollar.
And from Indonesia, we have PT Surya Esa Perkasa, what we call as ESA. They are still recording losses throughout the first half of this year. ESA's net loss even rose to 10.72 million US dollars from 5.77 million US dollars in the same period in 2020. Globally, many ammonia factories suspended production last year due to COVID-19, so ESA's production capacity hasn't returned to normal either. This condition make the price of ammonia soar to $813 US dollar per ton, up to 174% year-on-year. In the second quarter of 2021, the average price of ammonia fell again to $418 US dollar per ton.
So many for our presentation. Thank you for looking and hopefully useful.